Hi everyone, good evening. So today we are going to solve this problem by finding out the H parameter. The problem given is a common emitter transistor amplifier is represented by a four terminal network. It is given an input voltage of V1 is equal to 1 millivolts and a resistive load RL given is 10 kilo ohm is applied at the output of the network, and all the H parameters are given in the problem. Express these values in terms of H parameter representation. Okay, we have to express in H parameter representation, and we have to find the equivalent circuit, VL, load current, voltage gain, and inverse current gain. Sorry, current gain and voltage gains. So already we know how to represent standard format. So we have V1, I1 and V2, I2. This is with respect to input port. This is with respect to output port. So now how to write down is, we are going to write down V1, I2 is equal to H11, H12, H21, H22 multiplied with the values of V2, I2. So now when you see here, the equation of V1 is equal to, sorry, this is V1, I2 in terms of I1, V2. So H1, V1 is equal to H11, I1 plus H12, V2. And I2 is equal to H21 I1 plus H22 V2. So these are the two equations what we are having. These are very important if you want to solve. That's why I told to write down in this form. So now let's try to substitute here. So V1, how much is applied? 1 into 10 to the power minus 3 volts is applied. What is the value of H11 given? So H11 is 2000 into I1. What is the value of H12 given? H12 is 3 into 10 to the power minus 4 V2. And how to write down this? I2 is equal to H21. What is the H21 given? 50 into I1 plus what is H22 value given? 25 into 10 to the power minus 6 moles. Okay, so now we need to solve this equation and we want to find out the value of I1, okay, in terms of V2. So here, if you want to draw the equivalent circuit, already we have been drawn the equivalent circuit. Let's try to draw the equivalent circuit. So the equivalent circuit is a voltage source of V1 and an impedance of H11 with an, so this is regarding input port. The output port parameter we can write down like this as an dependent source with the terminals positive, negative. In the input port we want to represent the output port parameter. We are writing it as H12 V2. So this is positive terminal, negative terminal, so we will be getting this. And here we have I2. Okay, so if you are having an I2, definitely we'll have a voltage source V2 and a current of I2 is flowing like this. Okay, so here this is nothing but the output port values are H22 V2. So here we are going to have the parameter which is nothing but H22. The voltage at this point is V2, therefore our voltage at this point is also V2, and therefore our next H21 I1 is linked with input port, but we have to draw in output port. So that's why you represent with an a dependent current source that is flowing in downward direction. The magnitude of this value is H21 I1. Just we want to substitute. So just link it. Just substitute the values what is given in the problem. So this is 2000 ohms. This is H12 is H12 is 3 into 10 to the power minus 4 V2. H22 is, what is the value of H22? Is 25 into 10 to the power minus 6. What is this H21? This is 50 into I1. That's how we have to write down. So now we need to express this value. Okay. So how to write down the current I2? Here the current I2 is flowing in this direction. We want to represent the current I2. So how to write down the current I2? So generally we can write down the I2 as, and here he is saying that he is having a load. So this is the load given, and this is nothing but RL. What is that RL value given in the problem? Is 10 kilo ohm. This is nothing but 10 kilo ohm. Automatically the we have been already excited with a voltage of V2, and the current is flowing in this direction. Okay, so generally if the current flows in this direction, we know that how to write down the current I2. So this is flowing towards, but actually current will flow down. We know that I2 is equal to, what is the voltage at this point? The voltage at this point is V2 here. The voltage at this point is also V2 here. So the current flowing in this branch is nothing but I2. I am assuming I2 is equal to V2 minus 0 divided by R. What is the value of R? L. This is nothing but V2 minus 0 divided by RL is 10 kilo ohm. But we want the current in this direction. Okay, automatically this current we can write down it as I2. This current is flowing away from V2, but this is going from this direction. You can see here this direction are in opposite direction. Okay, automatically we are going to get minus V2 by 10 kilo ohm. So substitute this value in this expression. So this is nothing but minus V2 by 10 kilo ohms is equal to 50 I1, and this also will be coming to this side, which is nothing but minus 25 into 10 to the power minus 6 plus. Okay, so plus into minus is once again minus. Okay, so here we are going to have minus. So when you solve it and express the value of I1, okay, so the value of I1, if you perform this mathematical calculation, you are going to get minus 2.5 into 10 to the power minus 6 V2 is the value what you are going to get here. Okay, so this is the value of V2, and now use this value of I1 in this expression. Okay, when you intersubstitute, this is 1 into 10 to the power minus 3 is equal to 2000 into I1. How to write down I1 is minus 2.5 into 10 to the power minus 6 V2 plus 3 into 10 to the power minus 4 V2. Then automatically if you solve this, you are going to get V2 is equal to minus 0.212 volts. So this is the load voltage. What has been asked, the voltage drop across the load is nothing but VL, is nothing but V2. The voltage at this point is how much? Minus 0.212 volts. And how to find out the load current? Now substitute. So this is the first answer. Second answer, this current I2 is equal to minus V2 by 10 kilo ohms. This can be written as minus, what is the V2 value? Minus 0. 212 divided by 10 into 10 to the power 4. Okay, so therefore when you perform this current, you are going to get the current as 21.27 microamperes. So first answer we had got, second answer we had got, and we need to find out the third answer, which is nothing but V2 divided by V1, which is nothing but voltage gain. So what is the value of V2 we have been got is minus 0.212 volts divided by what is the value of V1. So V1 applied is already given in the problem. So V1 applied is 1 into 10 to the power minus 3. So this we are going to get as minus 212.7. There is no units. Why? Because voltage gain. So this is minus 212.7. Next one we need to find out. So we have been find out the H parameter equivalent circuit. We have been find the voltage drop. We have find the load current and voltage gain. We need to find out the current gain. So we are going to find out the next one, which is nothing but the current gain I2 divided by I1. So how to write down this current gain? So when you observe the circuit here, so let's try to redraw the circuit to understand in detail. In the circuit, you can see here, so this is the network given to us. The magnitude of this one is nothing but 50 I1, and this is a parallel source. This is nothing but H22 is 25 into 10 to the power minus 6, and this is having some load, and this is excited with a voltage of V2, and the current flowing in this branch is I2. Okay, so this is the current flowing in this branch. Okay, so the total voltage is also across the resistor, and we need to find out the total current. So how to find the current in any branches? We are going to apply current division rule. So I2 is equal to, what is the total current we need to have? I2 is equal to total current. Total current is 50 into I1. So here, what are the branches which are connected in? What are the branches which are connected in parallel? We have to identify. Okay. So here, I want the current in this branch. So what is the opposite branch? 50. So the branch which is parallel to this. This is the branch which is parallel. Opposite branch resistance is how much? So 25 into 10 to the power minus 6 moles. Okay. Actually, I want to write down the resistance. That's why I'm writing 1 by. So total current multiplied with opposite branch resistor. So this branch resistor we want to write down, but this branch resistor is nothing but in mhos. That's why I'm writing 1 by mhos. The ultimate units will be ohms divided by the sum of resistors. So what is this value? This value is, the value of this resistor is 10 kilo ohm. So 10 to the power 4 plus 21 divided by, so this is 10 to the power 4 is ohms, this is 1 divided by 25 into 10 to the power minus 6, this is also in ohms. So automatically if you write down the ratio of I2 by I1, then you will be getting this value as 40. So this is how we are finding out the currents in different values of getting the value. So hope you are able to understand. So this is very simple to understand all the methods of solving the problem. So very simple problem. If you want to revise, you can see here all the h parameters are given. We have to draw the equivalent circuit. We have to find the voltage drop. We have to find the current across the load and voltage gain and current gain at different points. So what is the units for this? No units. Voltage current by current, no units. So we have to understand the nodal analysis in very simple. So for example, you have an voltage of V1 and you have an resistance like this and you have an voltage source like this. Okay, so this is some V2. Okay, so this is some R1. So how to write down the current in this branch? I1 is equal to, so this is positive. The current leaving terminal is V1 minus 0 divided by R1. If you want to write down the current in, so this is the current I1 in this direction flowing from top to bottom. But if you want to write down the current I2, so I2 is nothing but minus I1. So now how I'm writing I2 is, I2 means the current is leaving. What is the leaving polarity? So this is 0. Whenever the current is flowing like this, the polarity is this is positive and this is negative. The leaving terminal is 0 minus V1 divided by R1. Now we can see here the value of I2 and is minus V1 by R1. Therefore, I can say that I2 is equal to minus I1. So I2 is equal to minus I1. So that's how we have to understand the things better. So hope you understood this problem. So if you feel the video is useful, please like the video and share it with your friends. If you have any doubts, let me know in the comment section. And if you're watching for the first time, subscribe to the channel. This is a channel for the benefit of students and faculty. Please kindly encourage this kind of channel for the benefit of students. Thank you. Yours obediently, Ram.